Okay, square root of P over Q, given that Q is equal to 2.25 times 10 raised to the power 6, P is equal to 3.6 times 10 raised to the power minus 3, right? Now, so instead of them to give us this and this directly in the square root, so it is done this way, Abi. So we need to know that square root of P over Q, Abi, is the same thing as square root of P is, look at where they put P, and we have P over Q. You write 3.6 times 10 raised to the power minus 3 first, followed by what? 2.25 times 10 raised to the power 6. So this is where we are going, which is equal to square root of, I told you when in this form of question, right? What we actually want to do is to make sure each of these number, the decimal numbers, are represented in whole form. Abi? So as a whole number, 3.6 becomes what? It becomes 36 times 10 raised to the power what? Minus 1. Minus what? Now, because it is 3.6, so for this to become 36, it shows this decimal point has to be moved once to the back. Moving once is where we got 1. But because the movement happened backward, was the reason why we have what? Minus. I hope that is clear. Now, this 3.6 is the same thing as 36 times 10 raised to the power minus 1, Abi. But we have 10 raised to the power minus 3 here. That one also has to be included. Multiply by 10 raised to the power minus 3. We now see everything over. So we'll do the same thing in the denominator. All right? 2.25 will also become what? 225 times 10 raised to the power. How many times do we shift the decimal point? To the front or to the back? When you move to the back, so that will be what type of power? Positive or negative? Minus 2. Then you say times 10 raised to the power what? 6. Right, then the rest is we apply laws of indices. Abi? Now, between this and this, no law of indices can take place because law of indices in this situation, right, works perfectly when bases are the same. And that situation, times changes to plus and division changes to what? To minus. So we can say this is equal to square root of, okay, let me adjust numerator and denominator first. Can I say 36 times 10 raised to the power minus 1 plus minus 3 over 225 times 10 raised to the power minus 2 plus 6. Minus 2 plus 6. Okay. Are you sure this is positive 6 or it's negative 6? It's positive. No problem. Now, this now becomes square root of 36, right? Multiplied by 10 raised to the power minus 1 minus 3. Hope you know where this and this changes to minus, right? Then everything here over what? 225 multiplied by 10 raised to the power what? Minus 2 plus 6 gives what? Answer me. 4. Positive or negative 4? So raised to the power 4. So let me continue here. Now, okay, let me conclude this. So I can say this is square root of 36 multiplied by 10, right? Raised to the power what? Minus 4 over 225 times 10 raised to the power what? Raised to the power 4. Right? So we say this is equal to square root of, now we can now apply laws of indices, Abi. So whole number goes with whole number, index number goes with index number. And look at it, between this whole number and this whole number, what operator do we have? We have division. Between this and this, we also have division sign, abi. So it shows we are going to say that 36 over 25, abi. You can see in order to combine whole number and decimal, 225, thank you. In order to combine whole number and decimal, the pattern they use or the rule they use is the place multiplication. Can you see that? Then after that, I want to combine this index number and this index number. The first index number I have here is 10 raised to power minus 4. This line changes to minus. What is the power we have here? 4. So, and this become square root of what? 36 over 225 times 10 raised to power minus 8. I hope that is clear. I love this question. It's a little bit different. Very different from the one we did yesterday. You'll see it now. Now, how do we interpret this? Interpreting this one is easy. Interpreting this one is easy, Abi. You may want to have challenge interpreting this, Abi. So I will tell you other ways by which that can be done. Remember when we are dealing with root, and no number is placed there, we assume it is in its basic form, Abi. As far as root is concerned, basic form of root is what? 2. Abi. That is why when most students see this symbol, what do they call it? They will shout square root, right? But if the degree of root is beyond 2, it must be stated. Once it is not stated, what number do we have here? 2. So, in order to interpret this now, we'll say, what is the square root of 36? Or, what number repeated itself 2 times and give us 36? What number is that? 6, Abi. So that square root of 36 is 6. Square root of 225, that will be what? That will be 15. Right? So we now say multiply by. Now, how do you find the square root of 10 raised to power minus 8? How do you find that? You can see that one does not sound nice, Abi. It does not sound right, Abi. Now, this is what we will do. Look at it. Now, I want you to tell me something that I've told you before. When you have x raised to power 1 over 3 in one word, how do you interpret this? How do you call what you have here? How do you read it? Okay, let me put it that way. How do you read this? What is the meaning of x raised to power 1 over 3? Mathematically. When you say x raised to power 1 over 3, you are speaking English. But I want you to speak mathematics now. What is the meaning of x raised to power 1 over 3 mathematically? It seems we've done a lot, but we've not really spoken about this. So it's better I tell you now. Is it clear? But the best you should be able to tell me is, this is a number having fractional power. Abi? Now, whenever your base has a fractional power, what it means in short is root. It means what? Root. But we don't know the nature of the root. Number below now tells us what type of root it is. Is that clear? So if it is 3, if 3 is what we have at the denominator, it shows this thing can simply be read as cube root of what? Of x. Torí tí mo kọ yẹn, x raised by 1 over 3 is the same thing as cube root of x. Radia, look up. What if I write this rather, x raised by 1 over 2. What's the meaning of x raised by 1 over 2? So I will tell you when we use these things though. So I want you to understand this first. When you see it, you should be able to know, okay, this is another meaning of what we have here. Unlike your English, you have word and synonym, Abi. What is the synonym for x raised by 1 over 3? It simply means cube root of x. Is it clear? So when we have x raised by 1 over 2, what is the meaning? It is something root of x, Abi. What root? Come and check. What number is there? 2, Abi. When dealing with root, if the number hanging here is 2, what name do you call that number? What name do you call that root? It is square root. So it simply means what we have here is what? In another word, it can be read as what? Square root of x. Is it clear? Are you sure? Look at this one. Let me come and use this part. What if you have 2 raised to the power 1 over 4? Or you read this one. Don't not English. Oh. We can say 2 raised to the power 1 over 4, but mathematically, how do you read this? What's the meaning of 2 raised to the power 1 over 4 mathematically? It means once the power is fraction, it means something root of 2, Abi. Now, what number do you have below here? You now say 4th root of what? Of 2. It's not clear, Rodia. Is it clear? Is it clear? Oh, yeah. Let's see this one too. 3 raised to the power 1 over 2. What's the meaning of this? It means what? Now, when do we use this? When do we read it as this? That's where I'm going. When do we do that? So, in a situation whereby it is not easy to detect what this thing will give us, that is when you bring all this form of interpretation into what you are doing. Is it clear? Is it clear? Look at it. I will go back to this place. We want to interpret to be able to get the final answer. Abi? So you said square root of 36 is what? Square root of 225 is what? Then square root of 10 raised to the power minus 8. You know that one do not sound nice. Does it sound nice? It does. Once it doesn't sound nice, then you convert it to something like this. Do you get that? Is that clear? Now, so what is the... Now we are looking for square root of 10 raised to the power minus 8. So what you will now do is this. Let me still use this place since I'm using it for just explanation. All right. We are looking for square root of 10 raised to the power minus 8, Abi. Square root of 10 raised to the power minus 8 can also be written as 10 raised to the power minus 8 raised to the power 1 over 2. Do you get that? Do you get... Okay, this is it. Normally what we should do is this. We should say square root of 36 over square root of 225 multiplied by square root of 10 raised to the power minus 8. What I just wrote here is the same thing as what we have here. It's like you distribute these roots to every item in it. Is it clear? Is it clear? But this distributing it one by one like this is like we are wasting time. Do you get that? So it is easy to interpret square root of 36, square root of 225. That one sounds more natural, right? But when you come to a number like this, finding the square root looks somehow. How do you now treat it? Any number you are dealing with that the square root is somehow, you convert it to this form. Okay, square root of what number are we looking for? The number disturbing us is what? What is the number? First of all, write the number out. 10 raised to the power minus 8 is the number disturbing us. Abi, what do you want to do about this number? We are looking for what? The square root. How do you write square root mathematically? So you can write it this way. Right? Because writing square root in the normal form will not still give solution, Abi. Once that one will not give solution, writing it the other way will make sense. Is it clear? That's why Yoruba have Oriki. By the time some things is happening to you at home, and your mom or your dad is able to start reciting that Oriki, what will happen to you? Orí yẹn á máa wúlé, gbogbo ìbínú tó ń bí ẹ̀yìn á kàn ṣe kíni, wàá kàn rẹ́rìn ni. Do you get that? Tó o bá ti try means kan tí o ti lọ, kí lóríkì ẹ̀. Kí lóríkì square root is writing it as index form. Is it clear? Are you sure? Now it is easy to operate now. Look at it. Since this is fraction, let me write this one too as fraction. Look up, Rodia. What can happen here? You say 2 in 8. Is it not 4? This now gives 10 raised to the power minus 4. Can you see that? Can you see that? So we now say multiply by 10 raised to the power minus 4. Is it clear? So this is one means, but we can't leave our answer like this. Is it clear? Though if you say this is your final answer, you are okay. But I don't want my final answer to be in this form. Since the question is given in standard form, let's also produce ours in standard form. Not just standard form in normally standard form must come in decimal form, not in fractional form. So we can say this is not yet in standard form. For this to be in full standard form, what do? Do this division. What is 6/15? Oh yeah, punch your calculator for me. That gives 0. What? 6 divided by 15. The first. Now we have 0.4 times 10 raised to power minus 4. Are you with me? Can you see this? And I also want to tell you one thing. When I taught you standard form, where is the normal position of these decimal points? Between what? What is the first number here? First number and number after it. Abi? But since we don't have any number after it, Abi, so we can say it is 4 times, right? Times 10. Now, for this point, normally point is here. What I'm writing now is ordinary 4. So what happened? It means I shifted this point from here to this place. Can you see that? Can you see that? Can you see that? Now, once you move a point, you must say times 10. I move a point to, its meaning is times 10. Do you get it? Now, how many times do you shift this point to this place? 1. Not only that, do you shift it to the right front or to the back? Move it to the back, then that will be negative. That is it. This 0.4 is the same thing as this. It is not clear. Is it clear? Now we still have this. You now say multiply by 10 raised to power what? Minus 4, not 4. Is it clear? So we now say our answer is going to be 4 multiplied by 10, Abi. Raised to power minus 1 plus minus 4, which is going to be 4 times 10, Abi. Raised to power minus 1 minus 4, Abi. And finally, our answer is 4 times 10 raised to power what? And this is the final answer. I hope this is clear. I hope it is clear. So who has this very answer? Yes, my good friend. I'm starting with you. Where is your work? Omuda, what is your answer? All right. So it seems you guys need more questions on this, Abi. Ma worry, ma ba yin wa to po dáadáa. I'm not giving you 10 in a day. I'm not giving 5 in a day. I will help you find 20 of this. I'll be giving you 2 every day for 10 days, making 20. By the time you solve those 20, so your brain will what? Be able to process it well. I like this guy. He just changed his work to fit my own. No problem. Mama, where's your own? See this guy. She can rub. Where's your own? See them. See what they are doing. Wọ́n kun ìwé ni, má kun ìwé tí ẹ o. Alájà rọ́ọ̀dì yá. Okay. The one you are talking about is easier. Look at it. So I could have done that here, but because it's a negative number, is it clear? Let me use this place to explain it to you. We have square root of, can you tell me the number? But I know we have times 10 raised to power 2. Something over something. Is it 9 over 9 over 12? 144. 81 over 144. When you walk to this level, you should interpret what you have. So it means you take the square root of 81, you take the square root of 44, and you want to take the square root of index number. So taking square root of index number does not sound nice. Is it clear? So once it does not sound nice, there are two ways to write square root in mathematics. That is where I'm going. What are the two ways? You're writing it conventionally, square root of x. This is one way by which you can write square root of x. Do you get it? So maybe this is what you should go and note. There are two ways by which you can write square root of any number in mathematics. This is general one. Is it clear? The other one is x raised to power half. Is it clear? So once you are interpreting, right, and the number you have here is not a whole number, or it is a number you cannot perfectly convert to a whole number, so this is what will follow. Is it clear? But if it is, it sounds well, it sounds reasonable, finding the square root of that number, so you can use this pattern. Is it clear? Look at it. What is the square root of 81? Nobody needs to tell you that. Even primary one student will tell you it is 9. Square root of 144 is what? 12. What is the square root of 10 square? You have two options. If it's a number you can process easily, you can say 10 times 10 is 100. Square root of 100. You can see this one too. We convert it to a whole number before we can do it when we are using this pattern. Is it clear? But if the number given to you is a type that dealing with it is not easy, is it clear? Then you come and use this part. Once you subject it to this pattern, you will see what you want to do. Now, I want to use the same thing here. What I have is 10 squared, Abi. So I can say 10 raised to, the number I'm looking, whose square root is to be found is what? 10 squared, Abi. You first of all write that number. What do you want to do about 10 squared? You want to find the square root, Abi. So how do you write square root? The other way around is to say 1 over 2. So because of your level, let's just say this is over 1. 1 now happen, 2 cancel 2, 1 cancel 1. So which is 10. Right? So then we now said 9 over 12 times 10. Is it clear? But one thing I will also tell you is once you are solving question of this pattern, under this pattern, it is better your standard form where you end up your solution should be in this pattern. Is it clear? It should not be in fraction. Is it clear? It must be in decimal in standard form. Did you get that? No worry, we don't need to talk too much about that. Right? You know, mathematics is not all about talking too much. It is about what? Doing. That is why some people define mathematics as a doing subject. Remember, every subject you are doing in school are doing subjects. If you want to know anything, you do what? You practice it. You do it. If you don't do it, you cannot know how to do it very well. I hope that is clear. So let us suspend the talking too much. Right? I'm already going to prepare 20 questions for you. I will be giving them 30, okay, good one. I will be giving them to you 2 every day. I hope that is clear. Okay, do we still have anyone copying this? If you know you are still copying this, write it as fast as possible so that we'll move to the next one. Auntie, what happened? No, there is something now. I think you are talking to somebody. To yourself. What happened? Do you offend yourself? Okay. All right. Are we done copying this? Oh, yeah. We've not done today's work. Oh, this is just the correction to yesterday's work. Can I rub this now? Koriba, are you okay? Rodia, hope no problem. All right. Abdullah and the other boy, please be careful there. Be careful there. Okay, the second question is, both are very simple. 27, 2 over 3, 64, raised to power minus half over 32, raised to the power minus 2 over 5. We have to simplify this. Since this thing comprises of times and divide, it shows this can be best solved using either law 1 or law 2. Law 1 or law 2. So that's that. Now, but when using law 1 or law 2, what should happen? In order for you to use law 1 or law 2, what we want to happen is base here, here, and here must be the same thing. Are they the same thing? Once they are not the same thing, then, and when you look at the type of number you have here, even if you try to adjust this, you cannot adjust them, all of them to the same base. It's not possible. Is it clear? Listen. It is not possible, Abi. What you now do in this situation is go and treat them individually. What do? You rather treat them individually. Once all of them cannot work in group, as a group, rather, then the best treatment you give to it is what? Individual treatment. Is it clear? Remember what that law 1, law 2 is talking about is that we must be able to do or change all the base to the same thing. But it's not all in all situation that every number you have here can have the same base. And this is the type of the situation. Once we cannot change everything to the same base, what do? Go and treat them individually. I try to satisfy all of you, but I realize despite how much I try to do that, you guys are still not okay. Then what's the best way? I'm going to treat you. I will have to serve you separately. That eat together. Islamically, it is nice we eat together. But what I observe is you still fight. Somebody has taken my spoon. Somebody put pepper in my body. Somebody do this. Then what's the best thing you think I should do? The best thing is, instead of you to kill me, instead of you to give me hypertension, I would rather live healthy. By doing what? I will serve. Okay, all the area, take your food. Fatima, this is your food. Khalid, this is your food. Fele, what is his name? Tayyib, this is your food. Koriba, this is your food. Islamia, this is your food. Abdullah and Abdulbasi, they are already having their own there. Lutufa, this is your food. So we rather go in that manner. I hope it is clear. Oh, yeah. All right, so we do it individually. So doing it individually means that what? What can you say? Oh, yeah, look at this 27. Now, we want to express this 27 itself in index number. How do you express 27 in index number? That is, what times what will give you 27? 3, okay? So that means we can write 27. Okay, that's one way. Another way, which was the one I taught you, is that what? Once the power is fraction, what do you do if your power is fraction? So you create this root, right? What do you now do? You put 27 inside, raise to power 2, you put 3. We are maturing now, then I will show you something else. Here we also can say square root, Abi. Draw square root, don't worry. You still normalize it later. You put 64 here, put minus 1 here, and what do you put under? 2. Here. Then lastly, you also can, because my power is fraction, is the reason why I'm doing all this. I can have 32 here, 5 here, everything here is power minus 2. Now, since we are treating it individually, we can now interpret it. Now, what number repeats itself 3 times to produce 27? 3. We say 3 squared times square root of 64 is what? 8. But remember, it is raised to power minus 1, Abi. We now say over 5th root of 32. That is what number will repeat itself 5 times and give us 32. So that is, do you know it, or you just said it? That is 2 raised to power minus 2. So let me continue here. Right? Can I continue? Now, what's the meaning of 3 squared? That is 9. Okay, inside bracket. You speak louder. Next time. Now we have 3 square is 9. But this is not normal. It is not normal, Abi. So like I always tell you, any abnormal number must be a fractional number. This one must also be in fraction for us to be able to remove the negative sign. So to remove the negative sign, what do? Okay, let's say times 1 comes up, 8 down, raised to power 1. Say everything over 1 here, 2 raised to power 2. With that, negative sign has disappeared. Just like Abdulbasit has disappeared from class. We just don't know because of who he disappeared. So that's exactly what is going on here. So here we say 9, or I can call it 9 over 1, Abi. Look up. Multiply by 1 over 8. So can I say over, or I can as well write my divide like this. Now this is what? 1 over 4. Or if, first of all, I can say 1 squared over 2 squared. What is 1 squared? 1. What is 2 squared? 4. But we are maturing indicially, Abi. We soon get to a time that all of these things we solve, we just use 2 lines and we are done. But for now, let us to this still be doing it what? In a gradual manner. So we now say this is 9 over 1 times 1 over 8 times 4 over what? 1. Can we cut where possible? 4 in 4, 1. 4 in 8, 2. We are left with 9 over 2. And what is if you want to use 4.5 or use 4 whole number 1 over 2, there's no problem. No, mathematically we don't need to use the same pattern. But what matters is you follow right step and you get the correct answer. Is it clear? No. Once you get anything different from this, you are wrong. You and your method, you are wrong. And you are supposed to be caned. Yes. Oh, yeah. 64 and 32. Yes. You what? That 64 is 2 raised to power 4. And that 32 is 2. All right, okay. He used another approach. Oh, yeah, let's learn that other approach. I've been skipping that approach. I will talk about the approach now. Right here, look up. Look at other means by which this thing can be done. Because our time is some question. You will not be able to use it, do it in this pattern. Is it clear? Thank God I've been introducing this pattern now. Now, this 27 itself, we can write it in index form, right? That is, we can say 3 raised to power 3, right? And you know this will contain power of 2 over 3 before, Abi. So you can say multiply by 2 over 3 times 64 here. So I want it to satisfy these two. There are 3 ways by which we can express this our 64 in index number. 4 raised to power 3, 8 raised to power 2, and 4 raised to power, okay, about 4. Okay, my teachers are even teaching me better. And 2 raised to power 6. What that means? Tell me more if we have more. But because of these two, I want it to suit these two here. So 64 there can be written as 8 raised to power 2, Abi, multiplied by minus 1 over 2. Everything over. So something raised to power 5 is what I want, Abi. What raised to power 5 can give me 32. You can say 2 raised to power 5 multiplied by minus 2 over 5. Is that clear? You can even see this one is even more faster than this one drawing of root and like this. But mathematically, what concerns you is you want to get the answer. Is it clear? But if you want to learn how to be as fast as possible, go and practice question. Practice a lot of questions. In fact, you can know it better than your teacher. Is it clear? Right. So what do? 3 cancel 3, 5 cancel 5, 2 cancel 2. What do we have left here? 3 squared. Can you see that? Yes. Multiply by 8 raised to power minus 1 over 2 raised to power minus 2. 3 raised to power 2. 8 raised to power minus 1. 2 raised to power minus 2, Abi. From here, you will do the same thing. And your answer must be 4.5. Once you don't get that 4.5, that means, so it's like you're having jedi and you are using anti-malaria drug, will it cure your pie? Your pie will still remain. Just like Abdul Basit is hungry and is asked to go and what? Cut grass. Will he be able to do it properly? He can never give results. So that's what we have there. I hope that is clear. I hope that is clear. I hope that is clear. Now, can we move to logarithm? Can we move to logarithm? Now, people are already checking time. If you know time is gone, no problem. We can. Oh yeah. What do you say? Now I'm doing it reversely. Where is the SS2 textbook? Yeah, too. You see yourself. So initially I wanted to start with logarithm of numbers less than 1, and now later teach you logarithm of numbers greater than 1. Yes? You want more work? Okay, is it classwork you want? So if I'm giving you classwork, you do it here. We are all not going to leave. You will do it in my presence here. You are not going anywhere. Okay. All right. The best thing, the best thing is, let's start with the logarithm of numbers greater than 1. So tomorrow, when I will have gotten that textbook, we will do the one of logarithm of numbers less than 1. Are we set? Are we set? Islamia, what happened? You are not set. Okay, let's do it in a simplest form. So we'll solve more complex question on it tomorrow. Oh yeah. In the next 15 minutes. Oh yeah, in the next 15 minutes, we're going to call it a day. So I can smell some lazy. Remember, we started 7:30. I pity you guys, though. Remember, the exam you are writing is in November. November or October? When is the exam? You don't know. Or you are not writing the exam again. When is the exam? December. So, we are almost in September. Today is 22. Oh, no problem. Don't worry, no problem. But one thing with me is I don't rush myself. Right? There's no problem. Let's move to logarithm now. Let's move to logarithm. We just begin with logarithm. Hope nobody is having issue with this, Abby. Yes, sir. All right. Now, you are not having much issue with logarithm. Only to remind you of what is a logarithm. This is not your first time of doing logarithm. And I also have to tell you that logarithm is also divided into 3 parts. First one is logarithm of numbers greater than 1. Second part, logarithm of numbers less than 1. Third part is theory of logarithm. That one involves the use of law. Just like you learn some law in indices, we also apply some law in the last part of our logarithm. Is it clear? But today, we want to talk a little bit about logarithm of numbers greater than greater than 1. Now, number 1, we are all able to, I believe we all can make use of four-figure table in finding logarithm, in finding anti-log. I hope we don't have issue with that. No problem. Even if we have issue in that, by the time we start solving question, we quickly remember, right? Yours is different from somebody who is just doing it for the first time. All right, let's see the few questions we are going to solve. Remember, I told you yesterday to come along with what? Your four-figure table. All right, evaluate. We have to evaluate 6.26 multiplied by 28.83. Can you see this? Can you see this? Can you see this? All right. Now, same what calculator does is what our four-figure table does. Is it clear? So some people call it a slide rule. Is it clear? Normally, you can just punch this into your calculator and give answer. But I want you to do it showing you're working using logarithm. So in order to do that, you create 2 columns. One column is called number. The other is called logarithm. In a more complex question, you can have log in like 3 columns or in 2 columns. So you can rule it like this, like this. Can I continue? Can I continue? I don't want discussion there. Now, the first number we have is 6.26, followed by 28.83. Now, before you lay your hand into checking this thing from your four-figure table, there is one primary assignment you are going to do. That is called what? Characteristic. Is it clear? That characteristic is similar to expressing this number in standard form. Let me explain. Let me use another approach to explain it. When you want to express this thing in standard form, look at this, 6.26. Express it in standard form. What will be the answer? 6 points in standard form. What do we call standard form? Is a mode of representing number whereby decimal point comes appears between the first number and second number. Is it clear? Yes. I want decimal point to be here. Be between 6 and 2. Is the decimal point where we want it or not? Yeah, it's there. So we write 6.26. And you must. So that's one of the things that make it standard. Say times 10 raised to power. How many times do you move here? How many times do you move here? 2. You do not make any movement. Ibo ló wà tẹ́lẹ̀ gangan? Ibi. Wo ohun tí mo kọ yìí àti tí mo kọ níbí. Is there a difference? Can you see that? Once you do not move at all, it means zero movement. No movement means raised to power 0. Is it clear? As far as logarithm is concerned, that is what we call characteristic. So don't move near this place. That's what we call what? Characteristic. Right? So I will not be repeating standard form again. I will just say characteristic. Is it clear? So what we mean by characteristic? Look up. Characteristic is decimal point has to be between 6 and 2. Do we move to this place before we have decimal point here? No. So that shows our characteristic is 0. But in case this concept of characteristics is not too clear to you, convert this number to standard form. Is it clear? So when you convert it to standard form, the power on your 10 will serve as your characteristic. Is that clear? So we just left standard form. That was my reason for using standard form to explain it. Is it clear? Now, let's see the next number. What's the next number? Normally, when you want to do it, if you don't want to waste your time, I want decimal point to be here. And where is it? It is here. How many times will it move from here to here? 1 time. So you just say 1 point. If you love going by standard form, write it. 28.83. Right? Now, how do you write this in standard form? 2.883 times 10 raised to power 1. Right? I move wasapo to I move saying it is positive 1. Is it clear? So here is what? 1. That was how our characteristics is 1. So I haven't done this. Now look your make use of your four-figure table. Right? So look for 62 under 6. Oh yeah, what is it from the four-figure table? Somebody should tell me that fast. No time. You are the one who wants to manage your time, and you have to be as fast as possible. Oh yeah, Khalil. Oh yeah, go to that back. There is another mathematics textbook there. Bring 2 other textbooks. I have 2 more textbooks there. Bring it. There's no time. Don't worry. I don't want calculator. Don't use calculator for me. You use four-figure table. Bring it. Oh yeah, bring those 2. Those 2 is okay. Those 2 are okay, Mr. Man. You cannot find it there. No, it's what if I I don't want that. You have to do use your four-figure table. Return that on yes, true, Nicholas. No. Oh yeah. Who has gotten it? 62 under 6 is what? 7966. Oh yeah, look at it too. 7966 or 7966. 62 under 6. What do you get? 7966, Abi. But you can see this is 4 digits. So what you do here is 28. Be careful there. 28 under 8, difference what? Difference 3. Oh yeah, be fast, be fast, be fast. No time. You can tell me I will to do the addition. 28 under 8 is what? 4594. Difference 3? 5. So that will be 4599, Abi. So you say 4599. Can I continue? Now, under logarithm, when we have times, the normal rule is times change to what? It is addition. Now, why? What's the reason for that? Because this number and this number are in base 10. Is it clear? So when base is the same, what happens? Times changes to what? To plus. Logarithm is extension of our indices. By the time we go to theory of logarithm, you will see how logarithm is derived from indices, from index number. I will show you that when we get there. So we know we are adding. Yeah, let's do the addition. 6 plus 9, 15, Abi. So carry that one, making 16. You carry the one again, 15. Carry that one, 12. And you carry the one here, this is 2. Are you okay? So once we are done with this, once we get here, we'll now look for the antilog of this number. So antilog of this number is the final answer. Is it clear? So we now say antilog of this gives the final answer. But when looking for your antilog, you will ignore, look up. When looking for the antilog, you are going to ignore number you have before the decimal point. Is it clear? Antilog will be for those numbers we have after the decimal point. So in that case, we will look for antilog of 25 under 6 difference 5. What is 25 under 6? Is it logarithm we are using or antilog? Difference 5. Are you sure? So this is 1810, Abi. So we write 1810. Right? Now the final job is to place decimal point. To do what? There are many approaches by which that can be done, but I want to use the easiest approach. The approach is, you remember when we were checking this antilog table, what happened to these two? We ignored it, Abi. So it is what determines the position of decimal points. So whatever number you have before decimal points, you always increase it by 1. The way we dealt with this number in case of number greater than 1 is different when the number is less than 1. So since we are dealing with logarithm of numbers greater than 1, the procedure I'm to talk about is what we should use. Is it clear? Whenever the number you have before this decimal point is a positive number, now in order to determine the final position where you place your point, increase that positive number by 1. You do what to the number? Increase it by what? 1. When you increase 2 by 1, it becomes what? 3. What that now means is from front, since this number is in the front, so from this front, you move 3 times. You do what? You move how many times? 3 times. So yeah, let's do the movements. From here, 1, 2, 3. So decimal point will now be placed here. Is that clear? And our answer is 181.0. You know, I can as well say my answer is 181. Is that clear? Is it clear? All right, let's take the last question for this one as time is gone already. We'll take one more question, then tomorrow we are going to solve more complex questions. All right, look at this. We have to evaluate 315.6. Continue talking there. 95.47 over 456.2 times 31.88. Don't worry, time is gone. Let's do it together. Hope nobody is still writing this. Are we still writing this? No? Can I rub this? Okay. Okay, so we say number log. All right, what's the first number we have? 315.6. Followed by what? 95.47. So when we are done with numerator, we shift our mind to what we have at the denominator level. Now, what is the characteristic for the first number? What's the characteristic here? So when they ask you to find characteristics, what they are trying to tell you is shift this point from here to here, or express this number in standard form. Whatever power your 10 carries, come and write it here. That's what we mean by characteristic. Hope it is clear. So, do we all agree this is 2 points? Then what's the characteristic here? 1 point. Do we agree? Yes. All right, then the next thing is, look up for this value from your table. 31 under 5 differences. Oh yeah, tell me, what is 31 under 5? Oh yeah. 1983. Or is it 4? Okay, 4983. Difference of 6 is what? Is what? Are you sure? 8. So this one will be 4991, right? All right, so I can see that boy is not in this class anyway. Don't worry, that's why we are making the video. Go and rewatch it. All right, 95 under 4 is what? 95 under 4. 9795. Difference 7. Are you sure? Yes. So that's 9798. 9798. Right? So between this numerator, what do you have there? Times. What do? You add. This is 9, 8, 7, 4.4. Is that clear? Is that clear? Now, something happened here. Whenever your denominator contains more than one number, is it clear? Then, so what will happen is you must move this answer. What we will obtain for numerator, you extend it to this place. Is it clear? Kọ̀ríbá ṣó gbọ́ ohun tí mo sọ. Ìsàlẹ̀ yìí tó bá ti ní ju nọ́mbà kan lọ, ìmọ̀ pé this is 2 numbers. Something times something. Times ló yẹ ká mọ̀ pé nọ́mbà méjì ló wà níbí àbí. This is one number, this is one number. Whenever we have more than one number in the denominator, then the result of your numerator must be moved to the next column. In that case, you create another column called log. Can you see that? Therefore, what you have here, you just repeat it here. 4.4789. It is not clear. Is it clear? Are you sure? What follows? We are done with numerator now. Let's go to the denominator. What's the first thing in the denominator? 456.2, 456.2, and what? 31.88. All right, 45 under 6 difference 2 is what? 6590. All right, hold on. 6590. Hold on. 6590. Difference of 2 is what? 2. Are you sure? Okay, not that yet. Not that yet. We will need to find our characteristic first. What's the characteristic here? So we say 2 points. And here, so 1 point. Now 6592, 6592. What about this one? 31 under 8 difference. 31 under 8 is what? Difference of 8. 11. That is 5035. Abi? So we'll say 5035. Look at your denominator. In between them is what? Addition. Abi? It's times, Abi? No addition. Times, we will change to addition. Good. 2 plus 5. 9 plus 3. 12. 5 plus 0 plus 1. 6 plus 5. 11. 2 plus 1 plus that 1. 4. You also close this one and break it down here. 4.1627. Is that clear? Is that clear? Yeah. Let me rub all this so that our work can look neat. I should continue. Now, so you can see this is the result of numerator. This is the result of denominator. What will happen? In between them, there is division. So that shows division in logarithm changes to whenever base is the same. Abi, what do you now do? You subtract. Now, 9 minus 7, 2. 8 minus 2, 7 minus 6, 4 minus 1, and 4 minus 4, 0. What is the next thing? You look for the antilog of this number, Abi. You now say the antilog. Let me write it very well. Antilog of this number, right? Remember, while looking for antilog, you will ignore the first digits, Abi, and move down to all the number we have after the decimal point. So what is 31 under 6? Antilog and not logarithm. Check your heading. Antilog. Check your heading. Antilog. Check your heading. Antilog. What do you get? 2071. Difference of 2 is what? Okay, you are a scholar. No problem. So 2071. Now, what happened to this number? Whatever number it is, you must increase it by what? 1. 0 plus 1 become 1. What do you now do? Move ones. B. Right? So our answer is 2.071. Is that clear? It now depends on the question. You can be asked to leave it in certain significant figure, in certain decimal place. Is it clear? So I believe we should not have a problem with that. We just treated that topic. Is it clear? Your exam is coming up. It's coming. You know our topic is becoming larger and larger. So I'll be able to pick questions from different angles. Let me give you an example. If at time I'm going to give you a question, it's going to be from JAMB question and Y class question. That's where I'm going to pick my question from. But the year is the only thing I will not tell you. But if you are the type that practice all the time, forget it. You've seen my question. Is it clear? JAMB and Y, go and be practicing them. So that's where we are going to round it up today. So your exam is the assignment which I'll be giving to you shortly.